Picture this. You're staring down your exam paper. The clock is absolutely ticking, and a tiny, seemingly innocent syntax error is literally about to cost you an entire grade boundary. Yeah, it happens exactly that fast. So, I want you to mentally lock in your answer right now. Look at these options. Which one of these lines of code is absolutely guaranteed to instantly lose you marks in your Cambridge IGCSE Computer Science exam? Is it A, B, or C? Seriously, make your choice right now. Okay, if you picked option C, congratulations, you just saved yourself from a pretty devastating mistake. See, option C is a massive trap. Writing generic mixed-up answers, like using lowercase case when the mark scheme demands absolute 100% precision, is just the fastest way to drain your score. Today, in this explainer, we're breaking down the exact mark scheme safe logic you need to survive. We'll be zeroing in on exactly how Cambridge examiners will heavily penalize you for confusing Python syntax with strict pseudocode standards. All right, let's jump right into Section 1, Mastering Selection Theory. Okay, let's dive into this. Selection. It's a completely fundamental programming concept, and you absolutely must know its precise definition for the exam. Basically, selection is the use of logical tests, which, remember, always evaluate to either true or false, to allow a computer program to choose between different execution paths. Think about it. Without selection, our programs would just run in a straight, boring, predictable line every single time. Selection is literally what gives our algorithms their intelligence. Now, what's really interesting about this slide is the strict casing you have to use. When you're writing in Python, the command words are exclusively in lowercase, right? And you use Elif when you need to chain multiple tests together. But man, when you switch over to Cambridge pseudocode, the whole game changes. The command words absolutely must be in uppercase. And instead of Elif, you are expected to use a case statement. Mixing these up, it basically tells the examiner you don't know the difference between an actual high-level programming language and an algorithmic design tool. Not a good look. Moving on, here is Section 2, Handling Multiple Options. So this is where the pseudocode case structure really comes in handy for those complex scenarios. And please, notice the absolute precision of the capitalization here. You declare case variable of. Then you list out your potential values, pop in a colon, and write the commands to execute. But wait, here is the absolutely critical part. You do not use the Python else to catch false tests at the end. No way. You must use the word otherwise. And, to wrap the whole shebang up, you have to conclude the entire block with in case. Now, I want you to really memorize that structure. Why? Because in just a moment, I'm going to reveal a hidden examiner clue that completely transforms a basic one-mark selection answer into a guaranteed full-mark response. It's a total game changer. But if you don't have the right framework to actually spot it, you'll miss it entirely on exam day. So stick with me here, because tuning out now means leaving those top bed marks just sitting on the table. To make that hidden clue incredibly obvious, we really need a mental model. We call this the high mark framework. Step 1. Identify the underlying concept, which, in our current case, is selection. Step 2. Locate the exact evidence or data in the scenario they give you. Step 3. Apply your logical, scientific reasoning. And finally, Step 4. Output your answer using precise examiner wording. I promise you, if you follow this 4-step loop, those generic, zero-mark answers will just disappear. Okay, let's put this into practice with Section 3, Tracing the Algorithm. And this brilliantly illustrates exactly how the logic works under the hood. This trace table tracks our variables as a user inputs a mathematical operator. So we've got num1, num2, choice, and answer. When the algorithm reads the user's input into that choice variable, let's say they type a plus sign or minus sign, the case statement physically executes by evaluating that specific input against its predefined list of values. It's not just guessing, right? It physically traces down the logic path that explicitly matches the current state of the choice variable. All right, time to raise the stakes. Section 4, Upgrading to Top Marks. Take a look at this generic student answer. The code checks if the choice is plus or minus. If it is, it does the math. Else, it prints an error message. Now, can you spot why this would score absolutely 0 marks? I mean, sure, it sounds generally correct to an everyday person, but to a Cambridge examiner, it's a complete disaster. Let's get the virtual red pen out, shall we? First off, this answer completely fails to name the exact variable being tested. What choice? It's just generic fluff. Second, the student used the Python else instead of the strictly required pseudocode term, which is otherwise.
And finally, they completely missed acknowledging the end case conclusion that structurally closes the whole block.
So here is your perfect top-band upgrade. The case statement evaluates the variable choice. It executes calculations for valid operators. Otherwise, it outputs an error concluding with end case. Do you see the difference there? This actually closes our open loop from earlier. The ultimate hidden examiner clue is using the exact scenario nouns provided in the question, like the capitalized variable choice, paired directly with the exact syllabus keywords, like otherwise and end case. You combine those two things, and boom, you unlock full marks. Let's move to and see how this builds into the bigger picture. Section 5, the systems software context. Because here's the thing. Whether you ultimately code your algorithm in Python or you map it out perfectly in pseudocode, it relies entirely on system software to actually function. System software is officially defined as programs that manage computer hardware and provide a platform for executing high-level application software. Basically, your operating system is what actually takes all this selection logic, manages the memory registers, and executes the physical computation. But listen, here is the brutal truth of the examination hall. You can have the most flawlessly structured pseudocode and totally perfect trace tables, but if your exam timing is completely broken, you're never even going to reach the final page to secure those marks. To make sure you secure that top grade, subscribe to our channel Ace the Exams at acetheexams_IGCE and jump straight into our last 7 days revision map explainer next. Because ultimately, you really have to ask yourself, what happens to your final grade boundary when the clock runs out while you're still stuck on question 3?